About 66 million years ago, a massive asteroid collided with the Earth near the Yucatan Peninsula in Mexico. This impact ended the era of the dinosaurs and resulted in one of the greatest species extinctions in history. That large asteroid wasn't the first to hit the Earth, nor will it be the last. Today, many people are actively trying to ensure that such an event never happens again. Learn more about asteroid impacts and how much we should really worry about them on this episode of Everything Everywhere Daily.
Music isn't really music until all the parts become one. Drums, bass, vocals, maybe some cowbell. It's a lot like business. Until all the separate parts of your company are working together, it's impossible to achieve your goals without harmony. Airtable can help. Deeply connect teams, data, and workflows. Build apps that adapt as your needs change. And give people the flexibility to do great work their way. This is how. Visit airtable.com today.
When our solar system was formed, it started with a big cloud of gas of hydrogen and helium and dust made of heavier elements. Most of that ended up coalescing through gravity into our sun. After the sun began to ignite via nuclear fusion, the solar wind it created blew out most of the lighter gases still lingering in the solar system. The heavier elements also started to coalesce via gravity and electrostatic attraction. Most of these heavier particles formed the planets and the various moons. However, not everything ended up as a planet or a moon. In fact, there was still quite a bit of matter flying around the solar system. Millions and millions of pieces of varying size never became part of a larger body and are still zipping around the sun today. Over the 4.5 billion years the solar system has existed, these leftover pieces have, on rare occasions, collided with each other and larger bodies. In the early solar system, this was happening quite frequently. However, every time a small hunk of rock collided with a larger body, one less hunk of rock was floating around. Fast forward to today, and there are still millions and millions of bits of rock floating around in the solar system. And some of these still hit the Earth. If you've ever been out on a clear night, there's a good chance you might have seen a shooting star. Most of the time, if you see a shooting star, you're witnessing something about the size of a grain of sand enter the Earth's atmosphere. However, much larger objects can enter the Earth's atmosphere as well. In 2013, a very bright fireball appeared over the town of Chelyabinsk, Russia. Hundreds of dashboard and security cameras captured it, and it has become the best documented meteor to hit the Earth. The blast wave from the object entering the atmosphere was strong enough to shatter windows for miles around and injured over 1,200 people. The object was estimated to be about 20 meters or 66 feet in diameter. Objects of this size hit the Earth less frequently, but they still do hit the Earth. Estimates are that there's an object the size of a small car that will enter the Earth's atmosphere about once a year. The larger the object, the more mass they have, and the more damage it can do. An object which is about 100 meters in diameter is known as a city killer. If it were to hit the Earth, it would have an impact similar to a large nuclear weapon, albeit without any of the radiation. This would be similar in scale to the Tunguska event, which occurred in Siberia in 1908, on which I have done a previous episode. The larger the object, the less likely it is to hit the Earth, and the greater the time interval between them. To give you an idea of what an asteroid can do, the Chiksalub Impact, which took place 66 million years ago in Mexico, was approximately 10 kilometers or 6.2 miles in diameter. That was enough to wipe out most life on Earth, and if the same thing happened today, the results would probably be similar. A large enough impact from a meteor is one of the things that could truly end life on Earth. Even an all-out nuclear war probably wouldn't be as devastating as a large asteroid hitting our planet. The late physicist Stephen Hawking considered an impact with an asteroid the greatest threat to life on our planet. The odds of this happening, however, are extremely low. These planet-killer-sized asteroids are rare, and impact events usually only occur over spans of tens or hundreds of millions of years. As our understanding of the Earth and the solar system has advanced over the last century, many people have begun to express concern about such impact events. Especially as we have been able to send out interplanetary probes and missions to asteroids and comets, the idea of planetary defense has become real. Seriously thinking about planetary defense began in the 1990s. In the movies, when there's some threat of an asteroid hitting the Earth, the plot usually involves sending up a rocket with a nuclear weapon to blow it up and save the day. That's actually not how it would work. The first step is just identifying the threats. In 1998, NASA set a goal of identifying 90% of the objects over 1 kilometer in diameter that crosses the orbit of the Earth. The 1 kilometer threshold was simply set because if something smaller than a kilometer hit the Earth, it would be really bad, but it wouldn't probably be an extinction level event. This goal was considered achieved in 2011. The good news about very large objects is that they're the easiest to see. They reflect light the most, and thus we can spot them well before smaller objects. While we were searching for these objects, the search was rather a disjointed effort. There was no single group, even within NASA, which was charged with planetary defense. That changed in 2016, when the Planetary Defense Coordination Office was established within NASA. The mission of the Planetary Defense Coordination Office is to catalog all known near-Earth objects, or NEOs, and also to start developing plans for what to do if we know something is going to hit the Earth. In 2005, the mandate to find 90% of all 1-kilometer asteroids was upgraded to find 90% of all objects greater than 140 meters. Our ability to detect and catalog NEOs is getting better and better. This is due to dedicated telescopes, which are designed to find objects within the solar system, and more computing power. One such telescope is the space telescope known as the Near-Earth Object Wide-Field Infrared Survey Explorer, or NEOWISE. These wide-field telescopes are in a way doing the exact opposite of what most astronomical telescopes do. Instead of trying to zoom in on something small and very far away, they're trying to collect images of the entire sky over different periods of time. Computers can then check these wide-angle images to see if there are any dots in the sky which have moved. If a point of light is found to have moved, they can then determine its location, extrapolate its orbit, and its mass. Just a few days before recording this, there was an announcement that an artificial intelligence program which was trained by humans making observations found over 1,000 new NEOs by analyzing 35,000 old images from the Hubble Space Telescope. There's currently a telescope under construction in Chile which will be known as the Vera C. Rubin Observatory. The Rubin Observatory will have a wide 3.5-degree field of view, and it will photograph the entire sky once every few days. It'll also be fitted with a 3.2 gigapixel digital camera, the largest digital camera in the world. First light on the telescope is expected in late 2022 or early 2023, and once it's operational, it should dramatically improve our ability to find near-Earth objects. There are now currently over 27,000 near-Earth objects of all sizes which have been observed and cataloged, and after the Rubin Observatory is live, it's estimated that it could increase by a factor of 10 to 100. Another telescope, known as the Space Surveillance Telescope, was deployed in New Mexico, and it's being moved to Western Australia starting in late 2022 to catalog the Southern Hemisphere. And these are just a few of the many sky survey telescopes in operation around the world, including the Catalina Sky Survey in Arizona and the Pan-STARRS and Atlas telescopes in Hawaii. So this is all really good news. We are constantly finding more and more near-Earth objects, and the odds that something will sneak up on us and wipe us out is getting ever more remote. More money is being invested in better tools using better techniques to find more asteroids. However, cataloging all the threats is just one half of the solution. Let's say we do know something large is going to hit the Earth. Well, then what do we do? For starters, the idea of sending up a nuclear weapon and blowing it up is not necessarily the best idea. For starters, in the vacuum of space, nuclear weapons would produce a lot of light, heat, and an electromagnetic pulse, but the blast wave wouldn't be nearly as large as it would be in an atmosphere. It would also depend on the composition of the asteroid and how solid it is. Many asteroids are thought to basically be a pile of gravel that's loosely held together by weak gravity. If we were to find something coming right towards us and we didn't have much time, nuclear weapons might just be our only choice right now, but there are better options. The best option, and one of the reasons for creating the NEO catalog, is to have plenty of time to prepare. The more time we have to prepare, then all we need to do is gently nudge the asteroid out of the way. For example, there is an asteroid called 101955 Bennu, which is about 490 meters in diameter. There is a 1 in 1,750 chance that it might hit the Earth on September 24, 2182. If such an object were to hit the Earth, it would be really bad. However, that's over 150 years in the future. Moreover, we've already sent a probe up to Bennu, the Osiris-Rex mission, which arrived on October 20, 2020. And it's bringing back to Earth about 1 kilogram of rock samples for study. Given enough time, you don't need very much energy at all to deflect an asteroid. A slight nudge can result in a massive change in the orbit of the asteroid over the course of decades. NASA is actually going to be testing this very soon. In November of 2021, they launched the Double Asteroid Redirection Test, or DART mission. DART is flying to the double asteroid known as 65803 Didymos, and it will collide with the smaller of the two bodies. And this will be our first attempt at trying to alter the course of an asteroid. The object hitting the asteroid will weigh 500 kilograms, and it will hit it traveling 6.6 kilometers per second. This should result in the asteroid changing its velocity by 0.4 millimeters per second. That might not sound like much, but that adds up over time. Given enough time, mass, and velocity, you can make a considerable change in an asteroid's trajectory. DART is currently scheduled to impact the asteroid on September 26, 2022. There are a lot of unknowns regarding what will happen with the impact, including how ejecta from the asteroid will affect its velocity. Once the collision takes place, we'll finally have some real data that we can use for planning future missions. There are all sorts of theoretical plans for how to deflect asteroids, which run from the aforementioned nuclear weapons to using a lander with solar panels and an ion thruster to provide a constant, gentle push, to just painting it black or white and letting the subtle forces of escaping infrared heat change its course. So while an asteroid impacting the Earth has the potential to be one of the worst things that could possibly happen, the good news is that the odds of that happening are constantly dropping. The more near-Earth objects we catalog, the longer the lead time we'll have before an impact, and the easier it will be to nudge it out of the way. We have come a long way in just 2 decades of cataloging asteroids. With constant vigilance and improved tools, we might be able to reduce the risk even closer, down to zero. Everything Everywhere Daily is an Airwave Media podcast. The executive producer is Darcy Adams. The associate producers are Thor, Thomsen, and Peter Bennett. Today's review comes from listener Bemidji, Paul, and Babe over at Podcast Republic. They write, "One of the best podcasts available. Gary shares with us his stellar knowledge and research on a plethora of topics. I'm a proud member of the Completion Club and enjoy all the work and time that goes into this amazing show. Oofta." Thanks, Bemidji Paul. You might not know this, but the very first podcast was created by Paul Bunyan. He was up in northern Minnesota one winter just as the lakes were starting to freeze. As he was talking to Babe, his blue ox, the sound waves coming from his voice caused ripples in the lake, which solidified as it froze. The locals could then hear his voice when they ran a log over the frozen waves in the lake. What they heard was Paul Bunyan asking people to support him over on Patreon. Remember, if you leave a review or send me a boostagram, you too can have it read on the show.